Hello and welcome to section 2.5, Implicit Differentiation. And in this section we're basically going to be taking functions that aren't necessarily in y equals form and being able to take the derivative of it. So we would go ahead and say, okay, well normally we're used to seeing functions like this that say 3x squared minus 5, and we take the derivative of it by taking y prime equals this. Well, in this equation down here, that's more implicit equation, would be something like x times y equals 1. And so the implicit form is that, and we could take the derivative of it, or the other option is for us to take the derivative, to solve it for y, and take the derivative of it. And so what you have to understand is that these y values, when we are going to take the derivative of them, are some function in respect to x. So that may be like y equals 2x cubed, or y equals 3x squared plus 7x plus 2. These y values are something. So when we do the derivative of them, we're going to use the chain rule. And so if I want to take the derivative of this function, you'll notice I have two functions multiplied together, so product rule is going to be necessary. So that means if I take the derivative of the first, the derivative of x, since it's in terms of x, I get 1. I leave my y alone. Then I'm going to add on, leaving the x alone, the first term alone, and taking the derivative of the y. Now remember, this y may be one of these functions. We don't know. So when I take the derivative of the y, there's a 1 here for the y, but then I have to take the derivative of the inside function with respect to x, which gets me dy dx. And then that will give me equals 0 when I take the derivative of 1. So if I solve this equation from this point, I'm going to subtract the y across the equal sign. So x times dy dx equals y, and then dy dx equals y over x, which doesn't look anything like the form of my answer, which is negative 1 over x squared. But you will notice that if I was to replace y with what it solves for, what y is equal to, which is 1 over x, then I will get the exact same thing as negative 1 over x squared. Now, most of the time, you're not going to want to solve it for y and do the derivative, but that's what's happening here. So as you look at this process, think about this. I'm going to go through the guidelines on the next page. So here are the guidelines. Differentiate both sides of the equation with respect to x. Then we're going to collect all the terms involving dy dx on the left side of the equation and move all the other terms to the right side of the equation. We'd factor out a dy dx from the left side of the equation, and then we're going to divide both sides by it. So this is all the steps possible, or almost all the steps possible. So we just kind of need to think about these things when we're going through them. And this isn't all the steps you're ever going to use, but this is the most of them. So here's another example. I have x squared minus xy cubed equals 0, and we're going to find out what's happening at this point 1, 2. Basically, we're finding the slope at this point. So if I go ahead and take the derivative of this function, well, 2x with respect to x is just going to be, or x squared is going to be 2x. Now again, chain rule. So if I take the derivative of the first term, the negative x here, I get negative 1, and that gets multiplied by the function that's there. So now I'm just following the chain rule to take the derivative of this. So then I add on, and I'm going to have to use big parentheses, I'm going to add on, now leaving the first term, and when I take the derivative of y cubed, I'll get 3y squared. But remember, any y's, when we take the derivative of them, are some function with respect to x. So we have to keep track that we are taking that y value with respect to x. So it's basically the chain rule. And so then all of this is going to equal 0. So I can kind of get rid of all these parentheses and multiply it all out and get things a little bit better. So I've got 2x minus y cubed minus 3xy squared dy dx equals 0. So I just kind of got rid of distributed, got rid of parentheses, things like that. And now anything that doesn't have a dy dx is going to move across the equal sign. So I'd subtract the 2x and add the y cubed. So that gives me negative 3xy squared dy dx equals, I'm going to say y cubed minus 2x. Anything that is multiplied by dy dx, so this is all just algebra, I'm going to divide by it. So dy dx, the slope is actually y cubed minus 2x over negative 3xy squared. Now don't panic if you don't get this right now. We're going to talk more about it in class, and we'll practice it a bunch so you'll have a chance to figure it out. So this equation right here is the slope of the original function anywhere on the graph. So now if I want to use the point 1, 2, well, then I'm going to put in 2 for y and 1 for x and simplify and see what I get. So dy dx at the point 1, 2 means I get 2 cubed minus 2 times 1 all over negative 3 times 1 times 2 squared. So just plugging in my values, that gives me 8 minus 2, which is 6 on top. And on the bottom, it looks like I've got a negative 12. So the slope at this given point is negative 1/2. And that's really what we are looking for this function. And when we go through and do this, just remember that we are taking the derivative of the function and then we solve it for dy dx. So we'll talk more and practice more of this in class.